Okay, hello everyone. Good morning. Good morning. Any questions about the lecture material? Was the reading list clearly accessible? All the details of the course clear? Okay. Okay, I've got the thing started. So we have, let me get the, I'm just going to connect my slides and we'll get started. Okay, so that should be working. Right. Okay, so today we are going to talk about economic growth. So we had a little bit of an introduction to economic growth last week. This lecture is largely about building the framework for economic growth. It's slightly a difficult lecture. Actually, it may be the most difficult lecture out of the 5 lectures. And the reason it's difficult lecture is it is a difficult lecture is because I'm going to go through the basic economic growth model. It's something that you just cannot avoid. Without the knowledge of the economic growth model, basically, people have conjectures about why economies grow, and the conjectures they have is usually associated with their own experience, and it's kind of a hodgepodge of causalities. Now, turns out that there are some important processes which drive the economic growth process. There has been a lot of work on this for the last 100 years. We understand what the main driving forces are, and we understand what the tangential driving forces are. Now, without the knowledge of this growth framework, it starts becoming extremely difficult to understand how infrastructure, how construction is going to contribute to development. So if it's slightly difficult, I'm happy to chat about it. I'm happy to answer any questions in the office hour. But I'm going to warn you that it's a bit of a difficult. It's a bit of a difficult lecture, and please do stop me if you're not grasping the concepts as I go along. Okay, let's start with something simple. This simply is UK's economic growth's long view. So it starts from about 1000 AD, and it's to present day. So as you can see, there's something interesting. There are lots of interesting things here. The first interesting bit is in this area here. What's interesting here is that this bit is so different from what happened before. So for a long time, almost up till 1800s, there was the real GDP of UK hadn't changed much. It had changed by small amounts, but it started off from a very, very low base. So you can see the growth rate on the bottom panel. So on the bottom panel, you can see the growth rate. So what you notice is that for the first 1,000 years, the growth rate is extremely volatile, right? So you can see the yellow period, which is less volatile, which is almost up till 1500. And then 1600 onwards, it starts getting more volatile. And then the volatility suddenly starts going down around early 1700s. What's striking is that the last brown bit is so different. It's different in two ways. One way in which it is different is that the accumulated growth at this point here had meant that there was a significant increase in GDP. And after that, the spike is spectacular. Now, we almost take this spike for granted. The spike here is quite spectacular. And if you can understand why the spike happened in UK, we can understand a lot about how we can engender this kind of a spike in other developing countries. The second thing to notice is in the brown period, which is the last 100 years, the volatility has gone down quite significantly. Now, I'm going to explore these things in the next few slides. So if we were to take UK's GDP for a shorter period from 1950 till today, the outline, this is what it'll take. On the right-hand side of the panel, this line here is the constant growth rate or the constant trend. And what that basically means is this. If we take from 1950 until 2017, and we assume that the economy goes at a constant rate, but reaches exactly where we are in 2015, then that path would look like this. Now, the economy has deviated from this. So in the 60s, the economy was growing at a faster rate than the constant growth trend. And then at some point it goes down, goes up again. It deviates from this constant growth trend. But it doesn't deviate that much. Now, the deviations, there is a large part of economics which is concerned about deviations and trying to reduce the deviation and make sure that the economy doesn't go very far away from the trend path it has. That is macroeconomics. That's short-term activity. We are not interested in that. What we are interested in is the long-term growth trend. And what basically we are really interested in is how do we shift this in this direction? Okay, so let me draw this slightly in a nicer way. Basically, what we are interested in is how do we increase it in this direction? So UK's constant growth trend is around 1.8% per annum. The US is about 2.5% per annum. So US has been going much faster over this period of time than UK has. And the question is, why is, so, we think of development as a bunch of developed countries, and then there are a bunch of developing countries. And, it's like, why don't the developing countries go faster? What can we do to make them go faster? Here, it's a slightly different question. But the answer, if you can get the answer to this question, it will also help us understand how to start off the development process in poorer countries. And the question here is, why does UK constantly grow at a lower rate than US? Or why does US grow at such a fast rate? Okay, and you'd have a very, very good sense of why UK is growing at a lower rate than US by the end of the lecture. Right. Now, if you look at the press, you often hear about unemployment, deviation from the trend, or the output gap. So this is also called the output gap. Or you hear about the inflation. These are again all short-run issues. What we are interested in is the long run. Now, turns out there is a bit of a dichotomy between the short run and the long run. So these deviations in the short run have impacts on the welfare, but the dichotomy generally that holds true is these short run deviations do not have an impact on the long run growth trend. Or that, at least that's what the empirical evidence is. So unemployment, as you can see, has grown up in the 1980s and come down again, but that doesn't have a significant impact on the long-term growth trend. So basically, we are not, at least for this course, we are not interested in these bets. And I thought it would be useful to point that out, that we are not interested in this bit because inflation, unemployment, these are the bits that pop up really often in the news. And some people think that these things are connected. They have a very, very marginal impact on the long-term growth trend. Okay. So now let's look at UK and US growth trend. So the dotted line in both sides. So this is US and this is United Kingdom. The dotted line is the constant growth trend in both graphs. In case of United States, it's growing. I was wrong earlier when I said it's 2.5. It's actually 3.21. So over the period of the last 100 years, the growth trend, constant growth trend for the US has been 3.22%. And for the UK, for UK, it's been 1.85. So it's kind of a bit of a puzzle. Why does US keep growing at 3%, 3.2% over a 100-year period? And why is UK growing at 1.8%? And the difference between the two is quite significant. What we also notice here in these graphs is that US has largely stuck to its trend. UK, around the 1920s and 1930s, started underperforming from its long-term trend, and then has caught up, and the catch-up happened here in this period. It's around just before the financial crisis, and then after the financial crisis again, it is lagging behind. Okay. So if you want to understand growth rates, first of all, we'll have to think about how to calculate growth. So let's take a variable, just any variable. It could be kind of the scoring rate of a particular cricket team, or any other variable. So what is a growth rate? I mean, I think most of you will not need this primer, but I just thought maybe just for the sake of completeness, we should do this. So if you start from X at the value of 2, right? If you start from X at the value of 2, then in the first period, if X goes from 2 to 3, the growth rate is 0.5. How do we calculate that? So what we do is we start off from a base of 2, and the change is 1. So that's 0.5, or that is equal to 50%. So the value has gone up by 50%. In the subsequent period, the change in the subsequent period is 3. And you divide 3 by 3, and so 3 by 3, and you get 1. And you get the point, right? So the change in this period is 1, and you divide it by 6. So you divide 1 by 6, and you get 1.7. So the growth rate of any variable is simply, you take the change and you divide it by the previous lag, and you get the growth rate. Now, this may be slightly less obvious. If two variables are multiplied, then the simple formula is that the growth rates are added up, right? So if you're slightly mathematically inclined, all you have to do is log of z is log of x plus log of y, and then you differentiate d log of z by dt, d log of x by dt plus d log of y by dt, and you get growth rate of z is growth rate of x plus growth rate of y. But this is not a formula that you need to worry about. You just need to learn the simple rule that if z and x and y are multiplied, the growth rates will be added up. So what that basically means is this. What that basically means is this, that, so let's take it. Yeah, these numbers are not looking good. Right, so so one here is 3 by 3, and 1.5 here is 3 by 2, and I don't know why this is wrong. This should be 2.5. Okay, right. Now we're going to talk about the reason we're talking about the growth rates being, if the variables are multiplied, the growth rates are kind of added up. The reason we're talking about is because we're going to define something called an effective worker. So we introduced this idea that a production process is basically a black box. So a production function is like a black box. You put in the capital, you put in the set of ideas, and you put in labor, and out comes the output, right? So the intuition is that you may have physical capital and you may have labor, but you need a set of ideas to put the physical capital and labor together. And if you put these set of ideas, the ideas allows labor to use that capital. Okay, so think about the coffee shop example that we were talking about last week. The coffee shop example we were talking about was, you can imagine a coffee shop where there is physical capital. So there's the coffee machines, there's the shop, there's the cutlery and crockery, all the physical capital. And then you have a bunch of people who've been hired to work in the coffee shop. Now, how the waiting staff and how the manager and how the barista uses the physical stock requires a plan or a set of ideas. And the better the plan, the more effective the workers are, right? So you can imagine a coffee shop where there is no plan and everyone's moving about in a chaotic way, and that means the workers are not productive. But in another shop where there is a very clear plan and workers are more effective, so the plan is much better, it makes the workers more productive. So if A is a set of ideas and L is a physical quantity of labor being used, and K is a physical stock, then the notion of an effective worker is A multiplied by L. And the idea of an effective worker is how effective the worker is. So if you take L equals one person working for 6 hours a day, if you increase A, that person becomes more effective, right? Now, it turns out that if you're interested in thinking of labor as an input, we can't think of labor as kind of a input without any control or any kind of influence in terms of how productive they are. So the A are the set of ideas that they they get to use the capital, whether these ideas are their own ideas or whether this is an idea provided by the manager. These set of ideas are the ones that makes the worker more effective. So the notion of an effective worker is take an individual, take the set of ideas they have, and the composite together, the idea plus the worker is the effective worker. Now, turns out that the key thing for a production function is not how much capital and how much labor you have, but it's about how much capital and how many effective workers you have. So effective worker, the quantity of effective worker. So if you increase A, you may have the same number of people working, but you have effectively a larger number of workers. Now, what is A? A could be a bunch of plan that a manager comes up with. A could be the human capital of the labor. So how skilled they are on their own to use the machine. So A could be a bunch of things, but the idea is within A, we have an ability to change the productivity of the worker. Any questions about this? I mean, this is kind of slightly, I think it was a new concept. So, the idea is slightly convoluted, but we'll see exactly why it's very useful in the production function. Okay, so I mean, if you have any questions, you can either speak up or put it in the chat. Okay. So the main idea, the thing that we're driving towards is this, that if K is KA plus L, and this is the only formula that you need to know about the growth rate, then the growth rate of K is del K by K. Its starting value. And that would be equal to del big K by K minus del A by A plus del L by L. And what that basically means is that the growth rate of K is growth rate of big K minus growth rate of A minus growth rate of L. So if this is the formula for effective worker, this is the formula for capital per effective worker, then the growth rate of capital per effective worker, the small k, is growth rate of big K minus growth rate of A minus growth rate of L. Now, what is the growth rate of L? That is simply the rate at which the population is growing, right? So in a country, the rate at which the workforce is growing is the growth rate of L. So if you look at it from a perspective of the economy, in UK, the growth rate of the labor force is about 1 to 2%. So let's take it at 2%. So the growth rate of labor force in UK was about 2%. Okay. What is the growth rate of A? The growth rate of A in UK is a general set of ideas the workers are, how productive they are, right? It makes sense at the level of the firm, but then all the firms come together to form the economy of UK. And in some countries, the ideas are generated and propagated in a more effective way. In other countries, they are propagated in a less effective way. The example of the ideas proliferating, the best example of ideas proliferating in a sub-economy is the way ideas proliferate in and around the Bay Area in the US, so the Silicon Valley. So basically, if you want to do something in technology, you have to situate yourself in the Silicon Valley, because just by being there and working in the firms, you learn a lot. And that means the ideas that you have about how to run technology firms or kind of create apps, it's phenomenal, right? Similarly, if you look at the hubs around Cambridge and Oxford in the UK, these are places where just by being there, you literally kind of, you absorb ideas on a daily basis. You go to coffee shops and you hear people talking, or you're walking in the streets, and I'm not kidding about this. You're kind of walking in the streets, and sometimes you hear really interesting conversation. You may not pick up ideas just by walking on the street, but basically every interaction you have, you pick up ideas. So if somebody's doing something innovative, you pick up that idea, you adopt that, and kind of you run with it. An example of ideas kind of having an impact on an economy is and I think I mentioned it last time, is the just-in-time production methodology that emerged from Japan in the 1950s. So basically somebody came up with the idea that you can just produce things just in time and you can become more efficient that way. And it kind of spread really quickly. So A is the rate at which the ideas, or sometimes we call them technology. When we think of technology, we think of technology as iPads and machines. But actually the social technology, the idea of A is trying to capture the social technology. And turns out what happens to A becomes absolutely crucial, okay? So keep that at the back of your mind. K, the big K, is basically what is the rate at which the physical capital is being accumulated in the society. Now, as I've been hinting since the last lecture, the physical capital accumulation plays a really important part in the growth of the economy, right? So the more capital intensive the firms are, the more productive they would be, right? So our objective in this lecture is to understand what determines this, the growth rate of K, okay? And the growth rate of small k is basically within the firm, what is the ratio of physical capital and effective worker? Is that changing for the society or is it not? Okay. Now that's what our production function looks like. It's a really simple production function, but it captures something very useful. There is a statistician called George Best, and he said, all models are wrong, but some of them are useful. And it's something that I always think of when I'm thinking about theory. The models are not meant to be right. And they're not meant to be right. And the reason they're not meant to be right is because reality is extremely complex. Reality is extremely complex, and it has a lot of details. And if you obsess about all the details, it just becomes impossible to comprehend what's going on. So any kind of scientific process requires models, and that requires removing the extraneous details and pinning down a core process, which is kind of important. And then once you've understood the core process, then you can kind of understand and kind of add the extraneous details. So a kind of good example from science of this is that when Newton discovered the idea of gravity, or he kind of formulated the idea of gravity, what he did was he put aside air pressure. So if you think of apple and feather falling, observationally, you're looking at gravity and the air pressure at the same time, and that leads you to make the wrong conclusion that feather falls slowly because it's lighter. Turns out the gravity is acting equally on the feather and the apple. The air pressure is an extraneous detail. If you keep it in the model, then you will never be able to understand that the fundamental force driving the apple and the feather down is the gravity. So all models are wrong. And the way they are wrong is because if reality is right, the process of modeling is to basically pin down the kind of core process. And in pinning down the core process, you leave behind a lot of details. And good modeling is where you get to the kind of core process and you're able to say, look, this is the core process that is going to deliver us results. All the other details we can add later. Turns out that's what we're trying to do. And here our objective is to find a way to engender growth, to kind of initiate the growth process, the development process in developing countries, and also find policies so that developed countries can grow faster. And if you want to do that, this production function is a parsimonious production function, which can use as a starting point, where we just think of this Y here is the output of the economy. K is all the physical capital in the economy. And AL is the effective workers in the economy, where L is the total labor force. So here L is the total labor force, and A is the set of ideas they have at the level of the economy, right? It could also, you can use A also to think about the human capital of the workers. Okay, so I'm just going to jump one slide and come back to this slide. So as we talked about last time, if you have constant returns to scale, then you can basically say, right, basically you can say there's the following. So if your constant returns to scale, and we talked about constant returns to scale last time, you can basically take the definition. The definition of constant returns to scale is that if you multiply all the inputs by lambda, your output will also get multiplied by lambda. So in this case, f of lambda k lambda al will give you lambda y. And this is true for any lambda. So if it's true for any lambda, if we set lambda at 1 over al, then that means y over al will give us f k over al and that can be written as y f of k, where y is simply y over al, that is output per effective worker, and small k is simply k over al, physical capital per effective worker. Okay, so this is what the next slide says. So if you have constant returns to scale, the production function that we have, y is f k over al, can be written as y, as a small y as a function of small k. That means output per effective worker is a function of capital stock per effective worker. So think about what that is saying. That is saying that the more capital intensive the firm is, the higher the output of that firm would be per effective worker. Or if you have constant returns to scale, that means scale doesn't matter, which means whether you're talking about the firm or you're talking about the economy, is exactly the same thing. So what that means for economy is if you have more capital stock, you will have more output per effective worker. So if you have more capital stock per effective worker in the economy, you will have more output per effective worker in the economy. So if you want your output to grow, you have to grow your capital stock. Okay, and you have to grow your capital stock at a faster rate than your labor is growing. Okay, with this, we're going to go back to the old slide, the slide earlier. And we're going to add a second assumption, a critical assumption. And the second critical assumption is this. The second critical assumption is that capital has diminishing returns. What does that mean? That means the more capital you add, the less productive that capital is, right? So again, we talked about this example last week, that if you're a coder and you have a terrible laptop, very jittery and it doesn't function properly, if you replace that with a more expensive, better quality laptop, it just means that you will be able to do more work. If you increase the quality of the laptop even further, that means it would increase your productivity, but it may not lead, your productivity may not leap by the same amount that it had leaped for the first change. After that, you can keep adding better and better quality laptop. The constraint becomes your ability as a coder. You can start getting supercomputers, but you will not be able to, given the capacity, you will not be able to produce more output. You can add multiple computers, it may not be productive. So capital, as it gets added, it has diminishing returns. What that means is that at the margin, capital is less productive as it gets added on. So the first unit of capital that you add is the most productive one. The next unit is less productive. The unit after that is even less productive. Now, virtually all production processes in the economy have this property that if you keep adding capital stock, if you keep acting, so in a construction firm, if you don't have a crane and you need the crane for a construction, the first crane that you get is going to be extremely productive. If you upgrade the crane, it may not increase your productivity by as much. And if you add more and more cranes, it may not be, at some point, the additional cranes may not be productive. Now, this is not a law. This is not an empirical fact. This is an assumption. So if this is true, we can work out logically what would happen. So the two assumptions we are making about the production process is that the capital becomes less productive as time goes on, so it has diminishing returns, and the production function has constant returns to scale. So scale is not important. So what happens at the firm level is reflected at the level of the economy, and what happens at the economy level is reflected at the level of the firm. Now, if you make these two assumptions, everything in the neoclassical growth model, or what we call Solow growth model, follows from there. And what follows is, at least, to me, it's counterintuitive. What follows is this set of ideas which have changed millions and millions of lives, because once we understood the growth process in the 1960s, governments across the world have a better sense of how to start off the growth process. And that just has meant that for the last 50 years, there are countries that have grown faster, accumulated more capital, become richer. South Korea is an excellent example of that. And there are various other examples of countries which have followed the kind of the policy prescriptions that come out of the Solow growth model and have benefited. So, it's very difficult to overstate the impact of these ideas. Let me take a customary stop and say, does anybody have a question? Your question doesn't need to be a question that reflects that you're understanding everything. Your question could be a really basic question. Your question could be, I don't understand this, or can you repeat this again? Because I'm speaking here to a screen, and if I was speaking in a lecture, I could see your faces. I would know exactly, what was getting through and what wasn't. Here, of course, I'm speaking to a blank screen, so I always, it seems to me that I'm convincing myself, and I am convinced. So I'm preaching to the converted. But if you have any questions, any doubts, please do speak up. You'll be doing you'll not only get the answer for yourself, you'll also be doing all your other classmates' favor, because if you bring up an issue, I clarify it, it's helpful to everyone. Okay, so let's represent this production function in a graph. So what in this graph, what we have on the vertical axis, is K, that's big K over AL, or it's capital per effective worker. Sorry. And what we have on the vertical axis is Y equals Y over AL. So output per effective worker. And what this graph is saying is simply this, that if you move from K0, so if you move from K0 to K1, so K0 is the original capital stock per worker. And if you move to K1, what would happen is that the production function of the economy or the firm would move from A to B. Now, the output capital ratio at A is the slope of this line. Why? Because the slope of this line gives you the slope of Y, small y, Y over K, which is the small y is Y over AL, K over AL. Cancel these things out. And so it gives you Y over K, which is output per unit of capital. So the slope of the line gives you output per unit of capital. And when you move to point B, this is the slope of the line. So the first thing you notice is the slope of the line has become flatter. And the slope of the line, we'll find, is crucial for us. Now, where does the marginal product of capital diminishing come from? Why is the capital becoming less productive? Because if you add a unit of capital stock, this distance here is how productive at the margin it has been. Now compare that to this distance here, and then compare that to this distance here. At the margin, the capital stock that you're adding, it may cost the same amount in the market when you buy that capital stock, but it's adding less and less to your output. Okay, and so this property is crucial. If the marginal product of capital is diminishing, the production function basically would get this shape. So, if you take the broad view, okay, take a really broad view, we find that the reason why this production function is shaped in this way, the reason why it's shaped in this way is because of diminishing marginal product of capital, the fact that at the margin, capital becomes less productive. The more diminishing it is, the more curved the production function would be. So the more diminishing it is, the more curved it would be. The less diminishing it is, the more the less the curvature would be. So diminishing marginal productive capital, what it does is it makes the production function kind of curve in. And why? Because as you keep adding capital stock, and I'm repeating this, so I'm being a bit repetitive, but this is quite crucial. As you're adding capital stock, because at the margin, capital is becoming less and less productive, at some point you hit a kind of a upper threshold, and your output will never go up beyond that. And that comes from the fact that the capital at the margin is diminishing. If the capital was not the margin, the return was not diminishing, if the capital was equally productive, then your output would keep going up. Okay. Okay. So now we are ready to kind of use the production function and try to understand how the growth process works. Okay, so I'm going to jump a couple of slides and look at this diagram. And this diagram is quite useful in terms of trying to understand how the growth process works. So what is this diagram telling you? The arrows tell you how the money flows in this diagram. So households work for firms. So households work for firms, and they get a flow of money in return, right? So households go and work in the firms. They provide the labor, they provide the ledger, they provide the managerial support, and they get, or they provide, they rent out capital. What they get in return is wages, profits, and rents. This is all coming to the households. Okay. What the households then do is divide their income into two different categories, right? So we're not saying anything profound here. It's a kind of mundane fact that whatever the income you have in a household, you can either spend that on consumption. So you can either spend that on consumption, or you can decide to save that, right? I mean, so any income that a household has, so any income that the household has, it gets divided up between consumption and saving, right? Now, it turns out the consumption is the money flows to the firms, and the firms in return give the households consumption goods. So, when you buy a cup of tea, when you buy a television, you're basically going to the firm, you're getting good in return, and you're paying them. So this yellow path here, that I've delineated, is the flow of funds going from households to firms, right? Now, it turns out that if you think of all the money in a particular period, that's flowing from the firms to the households, and the households are then deviating, the households are then deciding between consumption and saving, that means all the income is not being spent on buying things from the firms, right? So, let's take an example, a simple example. Let's say the income, 60% of it goes towards consumption and 40% of it goes towards saving. So that means if the households were paid £100 in income, they would spend £60 on consuming things, and they would put £40 as saving in the banks or wherever they go. So now, What that means is basically the firms are selling consumption goods to the households, but the households only buy 60 pounds worth, but the output the firms have produced is worth 100 pounds because that's become income, right? So we talked about last time how everything that's produced in the economy becomes somebody's income. So that means the output of the economy should be equal to the income in the economy. That's the simple national income accounting identity. I mean, I think it's really basic economics. I think most of you would have come across that. If you haven't, and you want to talk more about it, we can absolutely do that. So the idea here is simply this, that if 100 pounds is the output of the economy, right? So if 100 pounds is the output of the economy, 100 pound flows to the households. 60 pounds is spent back to the firms in the next period to buy consumption goods, and 40 pounds becomes saving. Okay. So the question is, what happens to the saving? So you put your money into the bank account, and what happens to the 40 pounds? So what happens to the 40 pounds is the bank lends the 40 pounds, finds kind of opportunities to lend. There is a small percentage that's lent to the household, but in the economy at the aggregate level, that percentage is relatively small, even though in the recent years this has grown a bit in the developed countries, but it's relatively small. Most of the money through the financial sector is lent to firms to make investments. And what are investments? Investment is basically buying capital goods. What are capital goods? So a machine is a capital good. It's not a consumption good. A crane is a capital good. A conveyor belt is a capital good. What is a consumption good? A consumption good is orange juice, lattes, kind of ready meals, sofas, television. These are consumption goods. Why are they consumption goods? Because you can't use a sofa to produce something new, whereas you can use capital goods to produce a set of goods. So you can use cranes to make buildings, which people would buy. So cranes are not consumed for pleasure or satisfying some kind of human need. Cranes are sold so that firms can use the cranes to build something else. So what happens here is that the saving that households undertake finds its way to the financial sector. So it goes to the bank, and from the banks, it goes to hedge funds, it could go to the stock market, but through basically the financial sector, which includes the banks, hedge funds, and stock markets, all that money gets routed back to the firms. So they get the money to invest. So the bank would go to the firm and say, okay, you need a loan. The firm would approach the bank and say, I need a loan. I need to buy some capital goods. And the bank would say, okay, here's the money. So that saving has found its way through the bank to the firms. And through that, they buy capital goods, right? And so that basically means is that the economy would be in balance only if 40 pounds of firms are selling 40 pounds of capital goods to themselves. So firms are selling 40 pounds of capital goods, which are financed through the investment in the economy, and so 40 pounds is what's happening in the capital goods market. 60 pounds is what's happening in the consumption market. Now, out of the 40 pounds, when firms get the fund for investment, they spend on two things. The first thing they spend is on repairing machines, or the first thing they spend on is kind of ensuring that the machine is taken care of, right? And that is called depreciation, right? So On the average, things depreciate at the rate of 2, 3, 4, or 5% a year. So if the depreciation, let's say, is in this economy is £5, so 40 minus £5, £35 is the set of capital goods, new capital goods. So depreciation is not new capital goods. The new capital goods is total investment minus the depreciation, and that's the new capital goods. And that new capital goods, £35 of capital goods, is new capital stock for the economy. So the way the new capital stock comes about for the economy is simply this. People produce things in the economy, they earn the income, they consume a part of it. Whatever they don't consume, it becomes saving. Whatever they save becomes investment. Take away depreciation from that, and you have no new capital stock, right? This is the flow of goods and funds in the economy. For the economy to be in balance, this flow has to be added together. So basically what's happening in this economy is, in this really simple economy, is this example, the firms are producing 100 pounds of output in this period. Out of that, 40 pounds of output is capital goods, they're machinery. 60 pounds of output is things that are produced for consumption. So firms, a certain proportion of the firms are selling 40 pounds of capital goods to other firms. And these other firms are getting these capital goods and adding to the capital stock. So in this one period, the economy has added 35 pounds of capital stock to itself, physical capital. So the physical capital stock of the economy has gone up by 35 pounds. This is basically the flow of funds in the economy, okay? And from this, you can already see where economic growth is coming from. Economic growth is coming because each period, the leftover output that is not consumed and that doesn't go to depreciation becomes capital stock. And that capital stock means that next year, firms in the economy have more capital stock. And because they have more capital stock, they can produce more. And because they produce more, the economic output of this economy increases. So the more capital stock you add, the more the economy's output would increase. Now, I have a simple example. So again, I'm going to repeat myself because some of you may have gathered this as I was speaking. The others may have kind of lost me somewhere along the way. So I'm going to add another example, a simple example. And it's kind of a really effective. I've used this example for a long time, and usually it's very effective in getting the point across. So think of a simple economy. Okay, sorry. Yeah, so think of a simple economy. Yeah. Can I just, sorry. Something's popping up. So you can think of this economy as an apple orchard. So think of an economy where everyone lives on apple orchard, and humans just need apples to survive. And you need apples to grow more apple trees. So everything is apples, right? And so the example here is, we're trying to think of an economy where we're trying to represent in a simple way. So let's think of humans who just consume apples and use trees to produce apples. So in this economy, let's say 100 apples are produced at the end of the year, and all the people who live on this apple orchard get paid equivalent of 100 apples. And they have to decide what to do with the apples they have. So how many apples to consume and how many apples to save. So in this example, they would basically consume 60 apples, and 40 apples would be put in a separate category, which is not being eaten to satisfy hunger. So what will happen to the 40 apples? The 40 apples would be turned into trees. Now, some trees may have fallen or some trees may have died for some reason over the course of the year. So in this example, 5 trees have died. So 5 apples are used to grow 5 more trees, but they are just replacing trees that already existed. And so that means at the end of this, the 35 apples would be used to grow more trees, and that is the additional capital stock. So next year, you'd be able to produce more apples. And why are you able to produce more apples in the orchard? Because the apples that were not consumed or not used to replace the trees that have fallen, which is 35 apples, were used to create and plant new trees. Now I can see the problem with this example. Apple trees take a long time to grow, and but this is an abstract example. It's not a realistic example. Okay, going back to this, how do we see this in equation? We can see this in equation. If Y is the output of the economy, then whatever is saved, so S here is the proportion of the income that gets saved. So in our example, S was 0.4. So 40% of the income, was saved, and 1 minus S was 0.6. So 60% of the income became consumption, right? Now, the output of the economy can either be consumed or be invested. The income of the economy is, which is also why income of the economy is consumed and saved. And from that, for the economy to be in balance, for the goods market to be in equilibrium, you would have Y equals Y. So that means C plus S equals C plus I. And that means saving and investment always have to be equal. If saving and investment are not unequal, then the goods market is not in equilibrium, which means either there is deficient supply of goods, or there's some demand for goods that has not been met. Okay. Now it turns out in the short run, you could have some deviations. And this is why you get kind of the up and down that you saw right at the beginning. We are not interested in this. We are interested in the long-term trends. So if you get oversupply or undersupply one year, firms correct that. And over a period of time, this oversupply or undersupply gets corrected because firms keep learning. If there is too much demand for apples, firms produce more apples. If there's too much demand for cranes, firms start producing more cranes. So in short run, from one year to another, you may have the goods market not being exactly in equilibrium, but we are not interested in that. We are interested in long trends, and in long trends, basically, the economy has a tendency where goods market tend to be in equilibrium. So if one year it is in disequilibrium, the next year it will be back in equilibrium. Okay, so the goods market equilibrium implies that all the apples that are not eaten become investment, and that investment can go into depreciation or addition of capital stock. So all investment, all the apples, all the apples that were not eaten, in our example, that was 40 apples that were not eaten. 5 apples became depreciation. They were replacing the capital stock, and 35 is the new capital stock in the economy. So the new capital stock in the economy is simply investment minus depreciation. So the new capital stock in the economy is investment minus depreciation. Okay. Okay, I'm just going to check. I think I have a chat. Dominic, why is capital diminishing? Dominic, capital is not diminishing. That's the assumption. If capital, so capital not diminishing. The returns to capital is diminishing, right? So I'm sorry, I'm answering your question a bit late. I just saw it, but it's not the capital that's diminishing. As you add capital stock, each additional unit of capital is less productive. So the returns to capital is diminishing. The return, and in this return is, if you put more capital stock, what is the return you get from that? That return is, another economic term for that return is marginal productive capital. So at the margin, the marginal productive capital, at the margin, the capital is becoming less productive, or at the margin, the returns for capital are decreasing. So as you add more capital stock, so capital is not diminishing. As you add more capital stock, it's actually the marginal productive capital is diminishing. Now, that is not a fact, that is an assumption. And we're going to examine when this assumption is reasonable and when this assumption is not reasonable. So if this assumption holds, then the version of the growth model we're talking about works. And when the assumption doesn't hold, then something else happens. And I'm going to show you some empirical evidence. When does this assumption hold and when does it not hold? Does that answer your question, Dominic? Okay, great. He said yes. So let's start by making a simplifying assumption, that there's no population growth and there's no change in A. So, there's no change in productivity of workers. Workers have the same set of idea today as they have tomorrow. So what we want to do is isolate the addition of capital stock, right? What impact does the addition of capital stock have? We want to isolate that, okay? And then we would start changing population growth, right? So because what we are interested in is trying to understand what happens to capital per effective worker. So if population grows, there's more population. So that means the capital per effective worker goes down, right? Because there are more workers in the economy. So let's fix the population stock. Let's say it's not growing, and let's see what happens. Now, it turns out that population stock growing at a small rate is a reasonable assumption for developed countries. So developed countries tend to have relatively low fertility rate. It's developing countries that tend to have a high fertility rate. So the population stock grows really fast. And so that's something that we're going to talk about. Your capital stock, okay, I'll come back to it. So right now, no population growth. So what happens in a world where there's no population growth? It's really simple. This is saving. So this is total income times the proportion you save. So, in our example, this is 0.4 times Y. And so, that's in our example, that was 40 pounds is the saving. Depreciation, take away the depreciation. So here, delta is the rate at which capital stock is depreciating. So capital stock K is depreciating at the rate delta. So we said it was equal to 5, all right? So if delta is, okay, if delta is 5%, and the capital stock to start off with was 100, that means delta times K is 5, okay? I'm just taking numbers. Just pulling out numbers. Okay. So delta was 5. So from this, that means that capital stock is 35. So all the equation is saying is take all the saving in the economy, take away the depreciation, and that's what you get is the new capital stock. Okay. So it's not saying anything profound. It's just replicating. So it's just kind of reflecting what we talked about when we looked at the flow of funds in the diagram. Now, all we have to do is divide everything by big K. And what you get is this. So on the left-hand side here, you have the growth of capital stock. This is the rate at which the capital stock in the economy is growing. And now you know exactly what determines the rate at which capital stock goes. Capital stock growth is determined by, so capital stock growth is determined by two factors. One is S, and the other is Y over K. Now, delta is also determines capital stock, but delta to a large extent is something, it's not an interesting variable because capital stock depreciates because of rust, because of overuse, and you can't increase or decrease the depreciation rate, and it's not going to have much of an impact on changing the fortunes of your economy. So depreciation rate is not particularly interesting, but the things that are interesting is saving rate and the Y by K. What is the Y by K? The Y by K is the output capital ratio. So remember what we learned about the Y by K. As you add more capital stock, your Y by K decreases. Your output capital ratio decreases. Why? Because at the margin, capital becomes less productive. So as the capital becomes less productive, as you increase capital stock, the value of Y by K decreases. Okay. Why do we know this? We know this from this diagram. So from this diagram, what we had learned is that if you have this shape, then the line that connects the origin to the particular point, the slope of this line gives you the Y by K. So as you add more capital stock, the Y by K decreases. You add more capital stock, Y by K decreases. And at some point, you'll reach this point. And if you add more capital stock, your Y by K is going to keep decreasing. So going back to this equation, what it's telling us is going back to this equation, what it's telling us is simply this, that the growth rate of K is determined by S and Y by K. So one way in which you can accumulate more capital is start saving more, right? So if you save more, you will have more investment in the economy and you'll have more capital stock. But the second thing it's saying is that as you invest more capital, at the margin, as you invest more capital, your Y by K will decrease and your growth rate would decrease. Okay. Now we can look at this in a very clear diagrammatic form, and hopefully that'll become much clearer when we look at it in a diagram. So here's the diagram. It looks like a bit of a complicated diagram, but it's not. So this here This here was the original production function. Okay, the yellow line there, the yellow highlighted line is the original production function. Now, if you're saving at a particular rate s, small s, right, and that's constant, then the saving line, the amount you've saved, that's the saving line, is simply lower than the production function. It's the production function, the output of the economy multiplied by the saving rate. So in this case, we're taking saving rate as 40%. So the yellow line, which is the line of the output, so you give me the capital stock, I can tell you how much output is being produced in the economy. The saving line is just a reflection of that, but it's been pulled down. Okay, so the green line that I'm going to highlight, the green line that I've highlighted is the saving line, and that tells you, given the capital stock, how much has been saved in the economy. So given the capital stock, the green line tells you how much is being saved in the economy, and the difference between the green and the yellow line tells you how much is consumed. So this is the bit that's being consumed, and this is the bit that is being saved. Okay, I mean, ideally, consumption portion would have been bigger, but if you draw the consumption portion bigger, then the saving line really goes down, and then it becomes difficult to see what's happening in the diagram. Okay, but the difference between the yellow and the green line is the part that's being consumed, and the height of the green line is what is being saved. Okay, shouldn't have done that. Okay, so here's the saving line. Let's say, so the other thing is that we also have the depreciation line. So given the capital stock, depreciation is a constant proportion. So the depreciation line is simply this. The blue line is simply the depreciation line, and the green line is the saving line. Okay, so in this economy, let's say you start from K0 capital. So at K0 level of capital, the total output of the economy is this. This here becomes consumption, and the rest here becomes saving. Okay, now within saving, we have two components. Within saving, we have two components. This part here becomes depreciation, and this part here becomes additional capital stock, right? So the total output, which is this part, gets divided up into saving and consumption, and then saving gets divided up between depreciation and capital stock. Okay, so this should tell you at least how to start with. Let's remove all this. Okay. Okay, so I think this is a fun diagram, or at least I find it fun. So now, if we start from K0, this is the amount, this is the amount which was total output that was produced. This is the addition of capital stock. Output minus consumption and saving. So consumption minus delta K. So this is the additional capital stock, this distance here. Okay. Now, if you draw a triangle, a triangle so that the two sides are equal, the capital stock, right? So we're assuming that this, we're kind of drawing a triangle, not assuming, we're drawing a triangle so that the two sides are equal. So that's what a triangle would look like, right? So if that's what the triangle looks like, then what we know is immediately from this diagram, so let's remove all the extraneous bits, is that this distance here, which is output minus consumption minus depreciation, additional to capital stock. So this here is the capital stock, becomes next period's capital stock. So an economy that starts at K0 in one period will move to K1. Similarly, an economy at K1 would add this amount of capital stock, which means it'll move to K2. Okay. Next period would add this amount of capital stock. It'll move to K3. Now, what's important here to notice is that each triangle is getting smaller and smaller. And the question is, why is each triangle getting smaller and smaller? The reason each triangle is getting smaller and smaller is because as you add capital stock, the capital stock at the margin is less productive. So the increase in output is smaller. So the capital stock that you're adding to the economy in the next period is smaller. So I'm saying this again, because the marginal returns to capital are diminishing, each period you add smaller and smaller amounts of you add smaller and smaller amounts of capital stock. And so what that basically means is that as you approach the point G, your growth rate becomes smaller and smaller. And when you hit G with almost a negligible growth rate. So that's like you drive from a distance and you're trying to park the car into a garage. So you're driving, the further you are from the garage, the faster you're driving. And as you get closer to the garage, you slow down. And your objective here is to make sure that you come to a standstill at the garage, because otherwise you will just bang, you just crash the car. So the further away the economy is from G, the faster it'll grow. And the closer it gets to G, the smaller the growth. And why is this happening? This is happening entirely because of diminishing returns to capital. So because capital at the margin is less productive, as the economy accumulates more and more capital, there's less and less left over to kind of add to capital stock. So the rate at which capital stock grows decreases as you reach the point G. Now, what happens at point G? What happens at point G is your saving is equal to the total amount of depreciation. So what is your saving? Your saving is S times Y. That was a saving. Depreciation is delta K, and they are equal to G. Why? Because before this, your capital stock was growing at the rate S, Y, K minus delta. So actually it was the difference between savings and depreciation. So it's the difference between savings and depreciation, which was leading the growth, right? So as you approach G, savings equals depreciation, capital starts growing, and at G, the growth rate of capital stock is equal to 0. Okay, let's go back and look at this again in forms of the diagrams. So in terms of this simple equation, what this equation is telling us is simply that the rate at which capital stock is going to grow is determined by the saving rate. It remains constant, is determined by the depreciation rate. So it's determined by the saving rate, which remains constant, is determined by the depreciation rate, which remains constant. So the only thing that's actually moving and creating the dynamic is the Y by K. As you act more capital, capital is less productive, less capital is left over, so the growth rate of capital stock goes down. And it keeps going down. And when it goes down to zero, finally, when this is equal to zero, so it finally goes down to zero when this is equal to zero. That means SY is equal to, that means SY by K is equal to del. That means SY is equal to del times K. That means saving is equal to depreciation. Now, we're seeing a really simplified version of this, but this was a revolutionary idea in 1956 when it was published. It was a culmination of 30 to 40 years of research. And Solow, Robert Solow, who published this, the model's named after him, he was obviously kind of using research that had developed over the 30 or 40-year period. There are lots of people involved in that, but for developing this model, he got a Nobel Prize, right? And the reason he got the Nobel Prize is because once we understood this, we knew a lot about how to make the economy grow. Now, this is the fundamental force of capital accumulation. We're going to add bells and whistles to this. So we'll add changes in A and changes in L. And if you understand this, adding changes in A and changes in L, so population growth and other things changing, is not very, very difficult. It becomes quite easy to do that. But this is the fundamental equation. Basically, if you don't understand this equation, you don't understand capital accumulation. If you don't understand capital accumulation, you don't understand economic growth. If you don't understand economic growth, then one really salient part of economic development, you will not be able to grasp that. And if you're not able to grasp that, then you'll be talking about less important tangential issues. You will not be talking about the main channel through which virtually all the developed economies, currently developed economies, have become prosperous. Okay, now, any questions on this? Any doubts? I'm going to add some bells and whistles. And this is the difficult bit. And now that we're over this, the bells and whistles that I add would become quite relatively easy. And then I'll show you some empirical evidence, to kind of talk about whether this makes sense or not. Okay, so this is a discussion we've already had about. Sorry, this is the discussion we've already had. In steady state, there is no change in capital stocks. The idea of a steady state is where things come to a rest. So in a steady state, saving equals depreciation. So the capital stock that's left over, or the kind of saving, the amount that people save in the economy is equal to the depreciation rate. So it turns out what it's saying is that it's inevitable for all the economies to move towards the steady state. It's almost like a force that's driving them towards the steady state. If you're away from the steady state, you'll grow really fast and get to the steady state. So one example of that, one famous example of this is Germany after the Second World War. So Germany, a lot of capital stock in Germany had been destroyed after the Second World War. And that just meant that after the Second World War, Germans woke up and they had a fraction of the capital stock that had been available to them before the war. Everything had just got bombed and in the war had got destroyed. And this is true for a lot of other countries as well, that the war effort had destroyed capital stock. Now, it turns out what we find is both Japan and Germany, the capital stock had got destroyed because of the war. They grow at an exponential pace, and they caught up to the old capital stock level within a period of 10 to 15 years. So destroyed all the capital stock. So, in terms of the diagram, what does that mean? In terms of this diagram, what does it mean? Okay, so let me just remove all this. In terms of the diagram, what this means is that if Germany was here in 1930, then the destruction of capital stock sent it back in this direction. And Germany then grew within a 10-year period and came back to the steady state. So the idea here is steady state is the equilibrium, like a pendulum. For a pendulum, the steady state is the point at the center. You swing the pendulum, it swings and it goes back there. In this growth model, the force is pushing the economy towards the steady state. So the economy would converge to the steady state really, really fast. So the question now is, why are some countries poor and why are other countries richer? And so the first reason that pops up is that countries must be richer because they have a higher saving rate and a lower depreciation rate. So it turns out a higher saving rate is viable. It's a viable thing. But lower depreciation rate is nothing that we can do anything with, because depreciation rate across developed and developing countries is not very different. So, it could move from 2% to 5%. It doesn't explain why US is, kind of 100 times richer than some of the poorer countries, right? So just depreciation rate would not explain it. Turns out the variation in saving rate also doesn't explain it. Variation in saving rate explains a little bit, but turns out we actually find that poorer economies tend to save more than the richer economies. So it doesn't explain why the richer economies have a higher capital stock per effective worker and why they have a higher output. One small bit here is that when we say it's a saving rate, it's not just a saving rate, it's a saving rate that finds its way to the firm. So if somebody in the economy saves and puts the money under the pillow, that doesn't add to the capital stock. It only adds to the capital stock if it makes its way through the financial sector into the firm and into investment, right? But basically the idea here is that the saving rate, the variation of saving rate across the world doesn't explain why some countries are so prosperous and other countries are so poor, okay? So the bit that would explain something useful is these assumptions that we'd assumed that population growth was 0 and the rate at which workers become productive was also 0, right? So if we take away these, we can remove these assumptions. So we assume that the economy, that the population of the economy is growing at the rate n. Okay, so the population of the economy, the labor force of the economy is growing at a constant rate n. And the technology, the set of ideas are improving at the rate g. right? So we know that every society ideas improve every period. So even if you're in a poor country, the ideas that are developed find your way. So better medicines, better ideas, ideas are very difficult to constrain within the borders. So ideas find a way, and societies develop new ideas which make workers more productive. Just-in-time production is just one example of that. You can talk. There are hundreds and hundreds of examples of ideas that have spread through the economy, and 5-10 years after they were developed, have become virtually universal. So turns out all we have to do now is work out the relationship, so we had defined effective capital per worker. We just have to turn that into growth rate, and we can use that. So if effective capital per worker is big K over AL, that means growth rate of big K is growth rate of small k plus G, which is the growth rate of A and N. That's all it is, right? So now we have this fundamental equation that we derived, the one we spent a lot of time over, which says capital stock is saving minus depreciation. Okay, that's driving the growth rate. All we have to do is use this kind of formula. So we have to use this formula and combine them, right? So capital stock, so growth rate of capital stock is the same on both sides. So that means the right-hand side should be equal, right? So if you take the right-hand side of the fundamental equation and take the right-hand side of the growth rate of capital K and equate it, this is what you get. And what you get here is simply growth rate of capital per effective worker is given by S y over K minus a bunch of these variables. Okay, so it's very similar. All that has happened is that we've accounted for N and we accounted for G. In the previous equation version of the model, we had assumed the N and G were equal to 0. So what we had got was growth rate of small k, a growth rate of small k. So the growth rate of K is Sy minus K minus delta. Okay, so yeah. Now, the bit that's interesting here is that if you're growing to a steady state, that means all the economies will grow to a steady state, right? And so whatever happens in the dynamics to steady state is not as interesting. What we're interested in is finding out how to increase the steady state in such a way. So how to increase the steady state from A to B. On one example of increasing the steady state from A to B is increasing the saving rate. Okay, so if you increase the saving rate, you're going to have higher per capita income. But here's something that's kind of within the weeds, which is very useful. So remember that we have worked this out in terms of K, small k, which is capital stock per effective worker. Okay, so turns out that this can be written as K over L over A. Okay, so if the growth rate of big K has to be equal, that means growth rate of K over L has to be equal to the growth rate of A, right? And what that basically means is that in the steady state, for the small k to be 0, for it to be a steady state, the capital accumulation has to match the rate at which the ideas are growing. And that means that you can, from this, say, and this is a slight bit of jump, take my word for it for a moment, but if you really want to know the details, I can give you the details on this. We can say that del y over y is del k over k is equal to A. So that is saying, sorry, I shouldn't have written it that way. What that is basically saying is that what we are interested in terms of living standards. So what we're interested in terms of the production process is K over AL. But what you're interested in the living standard, from the perspective of living standard, is Y over L. So in steady state, if K over AL stops growing, that means K over L grows at the rate of A. That means in the steady state, Y over L stops growing. That means Y over L is growing at the rate of A. And the idea here simply is that the living standards are improving because of new ideas. The faster the new ideas grow, the faster the living standards improve. The faster, the more productive the worker becomes, the faster the living standards grows. Now, if you're a bit lost on this, have a look at this. I mean, if you have questions, I'm happy to answer now, but have a look at this and go back and think about this. It takes a little bit of reading and thinking about. I have lecture notes that I'm gonna put up, which complement the lecture. But it will require a little bit of cogitating to understand what's happening here. But once you do, it's very, very rewarding, and it kind of opens up this whole world of understanding what's going on around you. Okay. So it turns out, why are we doing this? And the reason we're doing this is because diminishing returns to capital leads to kind of a slowdown of growth. And what we think is that once the returns diminish, you settle down on a steady state, and poor countries have settled down on a steady state. Now, it turns out there is something called endogenous growth theory, and it says that actually diminishing returns to capital only happens in developing countries. In developed countries, you don't get diminishing returns to capital. So in developed countries, the production function looks a bit like this. So you don't get diminishing returns to capital because the production function looks like this, because every time you add capital stock, the capital stock means that workers are working with that capital stock. And when they work with the capital stock, they develop new ideas, and these ideas filter through the economy, the ideas filters through firms, and they make everyone more productive. They just don't make the person who invents those ideas productive, they make everyone more productive. So, example of this is Silicon Valley is very, very productive because everyone's producing some ideas and sharing with each other. So it's a part of the idea that you produce these ideas while working and you share with each other, which increases the productivity of the level of the economy, so that a production function, which in a developing country, largely because they don't have too much capital stock to work with, it looks like this. But in developed countries, the production function starts opening up. So while the capital stock has diminishing returns, what happens is that it leads to new ideas. The new ideas get shared in the economy and make the production function shift up and become more productive. Now, it turns out infrastructure does exactly the same thing, which is, if you have some capital stock, but you have a limited amount of electricity, then your productivity slows down as you add capital stock. But as you add productivity, as I mentioned last time, it increases the productivity of the workers by a significant amount. So infrastructure plays the role of reducing the diminishing returns to capital. Now, this is the angle that I want you to understand. This is the kind of angle. So infrastructure, the way in which it kind of facilitates the growth process is by reducing the diminishing returns to capital. And it's not a coincidence that virtually all countries that developed, early part of the development process, developed some infrastructure. So one great example of that is the Erie Canal, which opened on 26th October 1825, and it ran 584 kilometers from Hudson River to Lake Erie. So, it's a kind of, if you know the map of United States, it kind of connected the eastern bit of United States to Lake Ontario. And in 1825, a canal was a really efficient way of transporting goods. So if you wanted to take your goods through roads, and this is also the period where railroads had not developed. The railroads developed a few decades later. But this is the period where, if you wanted to take your goods through roads, you had to take it on animals, and it was really difficult and it was insecure. But if you were able to move on water, you could move things much faster. So according to the study, and I have this, I have the study in a deeper dive readings in your reading list. The Erie Canal, once it was constructed, it cut down the transport cost by about 95%. I mean, that's a really significant drop in the transport cost. So now, what is Erie Canal? It's infrastructure. It's one particular form of capital, right? So we talked about capital goods as cranes and machines, but all infrastructure in the economy is also capital. With infrastructure, what happens is that privately owned capital becomes extremely productive. I mean, assuming that infrastructure is publicly owned. Infrastructure can be privately owned, but we'll get into the weeds a bit later in the course. But infrastructure, public infrastructure, what it does, it dramatically changes the productivity of the private capital, and it dramatically changes the shape of the production function, right? And so the reason why developing countries often stumble on the growth process is because they are not able to somehow bring up the infrastructure. And once they start building infrastructure, they start growing at a faster rate. Now, this is what I want to leave it at. I want to show you some interesting graphs. And this is the first graph I want to show you. This is from a shorter period, 1951 to 2017. So if you look at 1915 to 2017, on the horizontal axis, you have capital per worker. On the vertical axis, you have output per worker. So we don't have effective output per effective worker, and the reason is that it's very difficult. It's conceptualizing it is easy, but finding empirical evidence for A is more difficult, right? I mean, because A is intangible. But if I were to map capital per worker against output per worker, uh, the shape of China, so China's production function looks like this. India looks very similar here. Look at how France looks. So France shows a tendency. France shows a tendency. Let me use a different color. France shows a tendency of diminishing returns to capital in its early phases, but something happens in its later phases. It kind of bucks the trend. So early phase, it shows us as accumulating capital in the 1950s, 60s, and 70s, there's diminishing returns to capital, but it bucks the trend. And the reason it bucks the trend is because it starts developing ideas that start propagating. What happens to US is fascinating. US has no diminishing returns to capital. From 1950s, it has no diminishing returns to capital. And the reason it has no diminishing returns to capital is because the development of ideas in the US have been phenomenal. I mean, internet to a large extent is what's responsible for overturning the diminishing returns to capital. But the returns from internet, US as a kind of, had an early start in it, was able to use it far more effectively. You can see France using it, but it is able to use it with a bit of a lag. So this bit here corresponds to France's this bit, where the diminishing returns disappear because ideas flow with a bit of a lag to France, and the ideas about new technology are diminishing. Now, let's take a longer view, because if we look from 1951 to 2017, US shows no diminishing returns to capital. But let's look at 1840 to 1990, and the story looks very different. So in the earlier graph, we were looking at output per worker over capital per worker in this phase. And it looked relatively straight. But look what happens in 1950s. From 1920 to 1950s, look what happens. It's a phenomenal jump. And 1920s to 1950s is the war effort, the innovation through the war effort, and then the kind of emergence of, the emergence of the technical ideas that were started coming out of the US. And if we were to fit the production function, what happens is that the 1850 to 1920s production function looks like this. And if we continue, this is where it would have taken the United States. But from 1929 to 1966, something spectacular happens and it jumps up. And then you again see kind of a straight line and diminishing returns. But what happens in this period is phenomenal. Now, it's kind of useful to compare the production function of United States to other countries, right? So what I've done is I've taken the red line here. So the red and the blue line here reflect the production functions of the United States, right? So the red line here, here is United States, and the blue line is the later production function of United States. So United States jumps, the early part is put by a red line, and the later part is reflected by a blue line. And I've replicated the red and blue lines in all other diagrams. And you can see what happens to United Kingdom. United Kingdom is leaving the production function of the early 20th century and moving towards the United States production function of the 20th century, right? And this is because the ideas that are being produced in the United States, similar kind of ideas are being produced in UK, and is taking advantages. And these ideas are counteracting the diminishing returns to marginal capital. Now, it turns out Japan is following the production function of United States from the 1950s. So Japan is not an idea economy. Taiwan is doing exactly the same thing. It's producing, it's kind of accumulating capital, but it's accumulating capital without jumping and developing ideas which workers make workers more productive. And the fascinating thing is why. This is the fascinating thing. Why? If the ideas that are produced in the United States are available to United Kingdom, or the ideas that are produced in the United Kingdom are available to France, because ideas flow across border, the question is, why are Japan and Taiwan not able to acquire it? And this pins down the development problem. It pins down the development problem because developing countries have a low steady state to start off with, and they are not able to either accumulate capital or develop ideas. And if we can engender accumulation of capital or accumulation of ideas, we can start off the process. And in terms of accumulation of physical capital or developing ideas, infrastructure is key. Infrastructure is a particular kind of capital which is key for engendering the growth process. Okay, so I'm 2 minutes over. I think for me, at least, it was a bit of a challenging lecture because I'm trying to do a lot. This is usually, in an economics department, I teach this course. If I teach a growth course, I teach a growth course over a period of 10 weeks. I'm trying to capture everything in one lecture because I want to move on to infrastructure. But if you have any doubts, please do send me an email. If you have to leave, you can leave, but I'm going to stick around for a minute or two to see if there are any questions. Are there any questions that I can answer? Okay, there's something in the chat. Sabir, so Sabir's question is, A, in the production function, is the variable that improves the marginal product of labor and marginal product of capital. And A is the technological advancement that comes from infrastructure development, either in forms of improved road networks or better communication hubs like 4G or 5G. My answer to that question is, Sabir, A is everything that K and L is not. And A is the way we queue, the way we behave in the society. Because imagine a world in which everyone behaves in an honest way, you don't need the court system. That means you don't need to sign extensive contracts. If you don't need to sign extensive contracts, you can just work in a more productive way. Why does that happen? Because a particular society has a better social structure or some kind of a institution. So A is everything that KL and L is not. I'll give you a really, really simple example. If you walk around at 4 o'clock in the night in United Kingdom, and you were from Mars or from some other planet, you'd be fascinated at the sight of cars stopping in front of red lights for nothing, right? They're just standing there. There's nobody on the street. There are no cameras. The cars are just stuck there. Why are they standing there? They're standing there because they're obeying the laws. Now, imagine a world in which everyone starts jumping the red lights. That means the government has to spend money in enforcing that everyone stops at the red light. It starts diverting money away from education and healthcare and starts putting up enforcement mechanisms so that people don't jump red lights. And that's just a society which has become less productive. So A is anything that's not K or L. So A is anything that's not K or L, which improves the productivity. It's human capital. It's better institutions in the society. It's the legal and the judiciary system. It's virtually everything, right? And so A captures everything. Now, there's another way to look at it. You can look at A as a conceptual idea, or you can look at A as an empirical idea. So capital and labor are tangible. So we know what happens to capital and labor and what happens to output. These are tangibles. A is not tangible. So, the diagram that you see in front of you is actually a diagram about what's happening to K and L and what's happening to Y. Now, empirically, or from an empirical perspective, A is the residual element that doesn't get captured in KNL. So anything that doesn't get captured in KNL. So the notion of what A is A is something which is ideas, is technology, a set of social rules. So the thing that I'm going to argue in the next lecture, I'm going to expand on A, is that it's also the set of social rules, it's a set of institutions. So if you have better institutions, you have better institutions, you have a more productive economy. And the next lecture, we're going to talk about a paper where market access, improving market access, allows the economy to function in a better way. Why market access is critical. And so if you can increase market access, that goes into the A corner as well. Okay, so it's may not be very obvious, but what is A? It's a profound question, and we'll spend the next couple of weeks trying to answer what that is. A is. Okay. Any other question? I mean, if I've got you more confused, I'm sorry. Turns out what is A is actually the next part of the course. So it should become clearer what A is. I was trying to pin down A as some idea in this course, in this particular lecture, but I'm going to expand on the idea of A. That's the point. And I'm going to connect A to the infrastructure. And sometimes the idea is really simple, other times it's complicated. So one simple example that I gave you last time is, if you have better roads, it means that in developing countries, teachers get to schools and are less likely to be absent, and doctors get to hospital and less likely to be absent. If teachers get to school, they teach students, the workers acquire more human capital. If doctors get to hospitals, doctors treat patients, and less people are going to be ill. So the workers would be more productive. So it turns out, simply by building road, you're making the economy far more productive. Some part of that road is capital stock, but it's adding this extra value to other things which is making the economy more productive, and that's the part gets captured by A. I'll stop at that. Anything else? Any other questions? Any questions about the course? Okay. So I'm sorry for going over. I mean, hopefully the next 2 lectures would finish on time. Thank you, everyone. Thank you, everyone. Bye.
Thank you. Bye.